This video is brought to you by BTI Institute, a New Jersey leader in certification-based management training.
I'm Bob Phillips. I'm the Director of Agile Learning for the PMINJ New Jersey chapter. And tonight we have a special guest for our Agile discussion group, Mark Sheed. And I met Mark. I've never met Mark in person, but I've met him virtually many, many times. And he's actually at the Federal Reserve. He conducts these learning sessions every Tuesday, and the topics are always interesting, and the audience is across the entire Federal Reserve System. And when Nitin and I ran the Agile discussion group last month, I'd say 95% of the questions were about AI. So then after that meeting, I thought, wow, maybe Mark can help. So here's Mark, and so I'd like to now turn the meeting over to Mark. And again, thank you, Mark, for doing this for us.
Well, thank you for having me. I'm very excited to be here. So here, let me get my slides up. You tell me if you can see that. Is that showing up for everybody? All right. Okay. So we're going to be talking about agility in an AI world. And one preface I want to give here is that I'm going to give you some thoughts. Hopefully they'll give you things to try, some ways of looking at stuff. I've recently acquired a lot more experience doing stuff with AI, but it's changing rapidly, and my views may not be 100% accurate. And even if they were accurate today, they may not be accurate tomorrow. So take anything I say, test it out, prove it out, see if it actually works for you. But I'll show you what seems to be working for me and some of the ways I'm using things and some of the ways I've seen that you can shoot yourself in the foot. I will mention that the talks that Bob was talking about, the Agile Lunch and Learn, started at the FRB. It was just FRB originally, and then we kind of moved it offline. We still have a lot of people from various FRBs coming, but we've got people coming from Switzerland, and even had some people join from Australia. So kind of it's gone global. Anyway, we have a lot of topics related to agility, to software development, and more recently, a lot of things related to Agile. So if you actually go to that link, I don't think I've got anything scheduled for next week yet, but there's a place that you can actually type in an email address, and then you'll be on the invite list. If you see something, if you're on the invite list, you see something you like, you just click and say, accept it and sticks it on your calendar. If you're not interested, say you're not interested in it. So we've probably got about 4,000 people that get the invite, and I think usually 75 to 250 show up depending on whether they find it's interesting. So if you want to be on that list, it's agilelnl.com. Okay, so question for you. I threw this in the chat. If somebody can copy and paste it again, just in case somebody just joined. But how do you feel about AI? Do you feel it's going to propel your career forward? It's not going to affect you. It will put me out of a job, or it will put my low-performing peers out of a job. Just kind of curious what people are thinking with this. We've got 11 people that have answered stuff, and right now, most people think it'll propel their career forward, which I will say is a more optimistic view than a lot of the people I've talked to, particularly software engineers. Let's get a few more answers and see what people think. So one thing I want to mention about this question is this is a real question that we should be asking ourselves. There's some fundamental changes to the way software is going to be made. And I'll mention some stuff by Fred Brooks from the 80s. He's the guy that wrote the Mythical Man Month. It's interesting because some of the things he talks about with software becoming more efficient, AI seems to be doing the thing that he was saying. We don't think we have a way to do this, but if we ever did, it could be really, really efficient. And I think there may be the potential for that with some of the things with AI. Okay, so most of us are pretty positive about this, and I guess maybe that's why you come to this talk, right? If you thought it was going to put you out of a job, maybe you don't come to that, or maybe the percentage is skewed toward that. So let's talk about kind of the future of Agile in an AI world. One thing I want to point out is that Agile is about responding to change, which seems like it would be absolutely the most best thing to have and to be able to use if you're dealing with when you're dealing with AI and rapid technology changes. Next point I wanted to point out is that if you really go through the Agile principles, it's fairly AI agnostic, right? It tells about how we can work together to create software more efficiently. But it wouldn't really matter if you were writing in C or assembler, or actually just doing stuff just directly in binary, or using some positronic brain that we haven't even developed yet. it was written in such a way, the manifesto was written in such a way that it's not really tied to any one particular thing. And I think that's useful thinking about, because I think there may be, and my guess is that there's going to be a tendency towards saying, oh, that's Agile, we don't need that anymore because we've got AI. And I would suggest that that might be a really, really effective way to shoot yourself in the foot and end up reliving all the mistakes that we've made in the past with software development, just because we think things have gone away. Now, obviously, you've got to apply it the ways that work and experiment with things. But just throwing it out entirely, I think, is likely to end poorly. And part of that too is just kind of the importance of the principles, that when it comes to looking at the principles that have been found to produce good software, that absolutely should be your starting point when it comes to doing stuff with AI, not the last resort that you use if nothing else works. Let's see. Okay, here we go. So, question for you in the thing: what are these people doing? Is that not going to show us as we vote? Okay, we'll get a few votes and we'll look at the next thing. So you're watching these people in this room, which is evidently either a very hot or very cold room because there's vents on the ceiling, and connecting telephone conversations, programming, wiring, building a trap in their secret lair. I'm disappointed no one has gone for my thing of building a trap in their secret lair. But what these people are actually doing is they are programming the ENIAC computer. This is what programming used to look like. And I think this is useful to kind of think about, because if we assume that programming has always looked the way it's looked for the last 5, 6, 7, 8 years, I think we may miss how there's been some very big, very significant fundamental changes to the way that programming has changed over the year. And with that in mind, so look at these two people. I can't remember what their names are, but they're here programming these computers by running around and pulling wires out, and plugging them in somewhere else. So imagine if they saw this, right? What do you think they would think? What would their response be if somebody from the future came back to them and said, "Hey, this Apple script is going to set the volume of music playing on a computer," which would probably blow their mind, right? And then it's going to play the next track, and then set the current song to the name of the track, and then in that loop, and then display the dialogue now playing in the current song. So from their perspective, so vote for what you think would they think, oh, what a lovely programming language. Or would they say, this sure beats fiddling with wires? Or would they be like, this is witchcraft, black magic? What's the response that they might actually have when seeing this, when their paradigm of programming is we run around and plug and unplug wires? And so they'd probably be, on one hand, they might be very happy to not fiddle with the wires, but I would suggest that they would see this as extremely disruptive. Like, this is nothing like what programming means to them. Doesn't look at all familiar. The idea of the ENIAC playing music, other than just a bunch of relays clicking, that would just be totally foreign to them. And setting the volume and the current song track, and how would you play music with a computer? There's all kinds of things about this that would just completely blow their mind and not make any sense to them at all. And what I want to suggest is that the difference between the ENIAC and AppleScript is probably a lot smaller than the difference between AppleScript and where it looks like we may be going with AI development. That gap between AppleScript and AI development may be a whole lot greater than the ENIAC to AppScript, because from what the ENIAC is doing, you could actually probably sit down and walk them through and say, this is how this maps to this, in ways that I don't know that you could necessarily do when going from AppleScript to AI. But the big point I would just want to make, though, is we've had very big fundamental changes in the past. And when looking at AI, I think we need to be careful not to assume that it's completely new, like that we've never had big changes. So we can look to the past to get some ideas of how changes have been navigated in the past. But I think it's also to recognize that this may be an even bigger leap than some of the things that have happened in the past. So here's programmers in the 70s. So I don't know, do you guys know what these people are doing? Curious.
Punch cards.
Punch cards, yes. So when my dad was a programmer, years and years, I think this would have been before I was born. He was a programmer for ran programmer did payroll stuff for a small nonprofit in Joplin, Missouri. And so he had all the payroll cards, like, 2 or 3 feet payroll card that he was carrying, and he dropped them. They all fell all over the floor. So he very carefully picked them up, hoping they'd be in the right order, and they were, and it ran okay. But this is what programming looked like. It was like punching holes in these things, and that's how you program. Well, that looks a whole lot different than trying to program something in Java or programming something in .NET. That's a completely different experience. But yeah, this is how we used to tell computers what we wanted them to do. A matter of fact, I grew up using these that weren't punched because they stopped using them. This is what we would write notes and various things on because we had a ton of these in the house. And my dad just recently sent me a few of these because I was looking for them, and he found an old box of them in the attic or something that we still had from things. But then we also look. I mean, this was programming too, right? This is assembly language. So how different is this than the way that we're programming things today? And technically, anything that you can program in Java, you can, if you get low enough, this type of thing is happening behind the scenes, even if we're dealing with bytecode or something. But this is in the process somewhere. But that is not at all how we think about programming anymore, right? We're not thinking, unless you're like me and you're like interested in how it works. And I made a CPU simulator that you would actually run this on as part of class here a while back. It was a lot of fun, but that's not normally what people do. I'll recognize that's a weird thing to do nowadays if you're trying to just get code out there. So in I think it was '86, Fred Brooks wrote the Mythical Man Monk, which I highly recommend. It's an old book, but sometimes I think the older books give us a view on things that are easy to overlook, and maybe some perspective. But he wrote, I think this was an essay. I think if you get the newest version of Mythical Man Monk, this may actually be in it. But the essay was about no silver bullet. And in this, there's a couple things I want to point out. He talks about this, the idea of different types of stuff. Covering up my screen. So what's that first thing say? There we go. Essential tasks versus accidental tasks. So he says the essential tasks are the fashioning of complex conceptual structures that compose the abstract software entity. So the essential task of programming is how do we think about the problem domain, and how do we represent the things that are in the real world in some type of abstract way that we can then get into code. The accidental tasks are the thing of actually representing these abstract entities in the programming language and mapping these onto machine language, space and time and speed constraints. So most of the stuff that we think of a developer sitting down and writing code is what he's calling the accidental task. The essential task is that stuff that happens to get us to that point. And then he talks about that he felt at the time that we were at a point. Sorry, I'm moving my picture of you guys all the way so I can read it. So he says it appears that the time has come to address the essential parts of the software task. So he's basically saying that with the higher level programming language, moving away from things like assembly language, we've gotten to the point that he was seeing there may not be as many gains to be had of trying to make programming languages better. And he was dealing with ADA and some things like that. And I think that's accurate. If you look at how long it takes to write something in a programming language like ADA, software libraries and everything being the same, and the amount of time it would take to write it in C# or Java or something like that, there's not a huge difference. It's not like one is going to be 10 times faster other than just the libraries that we've built up, but there's no reason those couldn't have been written in ADA as well, or some other programming language. So what he's actually suggesting doing is, first of all, avoid constructing what can be bought, use off-the-shelf software, which you probably always heard people talking about doing. Use rapid prototyping as part of a planned iteration in establishing software requirements. Grow software organically, adding more and more function to systems as they are run, used, and deployed. This sounds very much like Agile, and this was like '86. And identifying and developing the great conceptual designers of the rising generation. So I think a couple points I want to make with what he's saying here is, I think on one hand, what he's describing as being the essential parts of programming, I don't think any of that actually changes, even if you're using AI to do absolutely all of your programming. I do think that the accidental tasks, though, that he's saying he doesn't think they can speed up anymore, AI does have the potential to do that, which means that these tasks that he's talking about down here become even more important. Another quote from this is, okay, so as we looked at the horizon a decade hence, so that would have been like 96, right? There's no single development in either technology or management technique, which by itself promises even one order of magnitude improvement in productivity and reliability and simplicity. And then he's going as to why he's examining the nature of the software problems. But at his point, he's saying, looking over, we don't see anything that might actually really speed things up. And I would say AI used well might be not necessarily the silver bullet, because I don't think it just solves everything, but it might be that thing that he was looking for that he was saying he couldn't see at the time. So is AI a silver bullet? Does AI reduce accidental complexity, and does the AI reduce essential complexity? So one thing I think to think about is when it comes to the accidental complexity, AI can remove a lot of the tedious work of doing things like running a deployment, restarting the application, troubleshooting a startup issue, or figuring out why a test is flaky. And I'll show you some of these things here in a little bit. I've started building an application with AI just to get my feet wet with stuff. And it's been interesting. I picked a program I'm doing in Common Lisp. So if you want to have something that you really want to see how AI works, pick a language that you're not super good at. I'm getting some familiarity with it, but a language that you're not really super good at, all the different, all those little things you've got to figure out, like with Java in the early days, it was like how to get things, the class path worked out. Those hundreds of little things you've got to get right to do stuff. And it's really amazing how good AI is at getting those things to work. Those things that like trip people up for an hour, then half an hour, you end up searching on Google, like, oh, okay, there's, that semicolon can't be there or whatever. Those types of things, I think it actually can reduce a lot of what Brooks refers to as the accidental complexity in ways that he was saying he wasn't seeing was possible. And I think that may be, if you go back and look at his view of software, I think that shift may be one of the biggest things that comes out of AI. So this is why I recommend going back and reading the old stuff. But when it comes to the essential complexity, the things that he was saying to actually reduce that was doing things like growing software organically over time. So one thing I see AI has a big potential doing is reducing the fixed cost of a change. So I was working on a project years ago, and the cost of getting a change through to production would take, I think it took 12 people testing for 6 weeks. Or was it 6 people testing for 12 weeks? Well, amount of effort works out to the same either way, but it was significant. Well, when there's that much fixed cost to deploying any change, there's no way you will be willing to make a 2-line change and deploy it on through to production. In this particular thing, we did a rewrite and got that time down from them only being able to deploy 6 months to them being able to run all those tests in 2 hours. And they got to the point where, as a matter of fact, I think they still are deploying on average every 2 weeks. Which had real monetary value for them. I think AI has the ability to do a lot of those things now, lowering the accidental complexity, which means these other things become even more important of being able to grow the software organically, making a small change, getting it out there. And then because you haven't sunk a whole bunch of money into it since you used AI for it, if it doesn't work out, well, rolling it back, maybe just trying it with some users, it being freer to throw things away if they aren't actually making an improvement. So as the fixed cost gets down, of a change gets down closer to zero, most of the time will be spent trying to decide what change should be introduced. So how are we managing the process of deciding what the next most important thing is? And that becomes the biggest, I don't want to say bottleneck, because it's not necessarily, that has negative connotations, but that's the thing you're doing more than we're waiting for developers to code stuff and get it tested. And this is what I see as potential. So I don't know if you've seen this chart, but this is and this is a little bit dated because this was GPT 5.2. There's this test, and what they do is they take a bunch of different deliverables that humans may need to produce in their job. And then they take experts in those fields and produce some of these things. So it could be a marketing plan for X, Y, and Z. It could be what was one I did with someone? It was the remote access documentation and policies. All those things that are part of people's jobs, things that they produce. And they have humans produce them with the same request as they have AI do it. And this is showing GPT 5.2. They were getting 49.7% of the time when people were judging them, they were saying that the AI was superior to what the human was doing. So like almost half of the time. And that's pretty significant. And then the different other different models. They haven't updated this for a while, which makes me think that this is from OpenAI. It's possible that the other models are outdoing them, so they're going to wait till they outdo them once and then print it again. But what's even more interesting here is that the 70.9% at the time for GPT 5.2 was how often either the AI won or was deemed to be a tie with the human, which means that for this work that they were doing things with, 70.9% of the time, there was no reason to have a human do it for these things. Now, let's recognize OpenAI has a self-interest in this being as high as possible, right? This is what they sell, but this is I don't think we should ignore this just because it comes from OpenAI. A more recent chart that you may have seen, and this is from Anthropic. This was showing, and what they were trying to represent here is saying, here's the blue represents the theoretical use of AI in these different fields. So if you notice with computers, math, business and finance, and the management, it's at about 90, maybe 95% of the work that can be done. Once again, Anthropic has very much self-interest in this being as big as possible. But the red is showing how much they say is being observed that's actually happening, probably from looking at what people are using things for. So their model is showing that there is a very large, there is a lot left to potentially be done. And I think that's a useful way to think about it. Now, will all those things, not necessarily all of those things will it do at the 80%, that we were looking at before, but it may get better at some of them. But this should be, I think, a wake-up call for people, well, for people like me who early on was like, okay, AI, it's glorified spell check, and I really like writing code, so I'm not going to spend any time looking at that. The people that are able to grow that red part in their organizations are probably the ones that are going to continue to be around. So let's think about a different or who are going to be able to grow in their careers. That's probably going to be a very vital part of many of our careers going forward over the next 10, 20 years. If we look at another disruption, so this is the tractor, right? Extremely, extremely disruptive to the way that work was done. Many agriculture work was greatly done by farm hands doing manual stuff. Even when you were using horses and stuff like that, you had to take care of the horses, you had to take care of the mules, you had to have somebody driving the mules, and often lots of people. It wasn't a one-man job to go out and plow a large field. There was lots of stuff that had to happen. So tractors came out and they started replacing a lot of the things that were being done with the horses, but also a lot of things that were being done by hand. And if you think about it, so farmer gets the first tractor, and I grew up on a farm that was, so the house I grew up in was built in like 1889, or 1889, something like that. And it was the second house that was built because there was another house that was built before that. So they were, very much in the time before tractors and then transitioning to tractors. So on this farm, there's a tractor, they get it, they start using it. There's all these farm hands that are helping with stuff. Well, one of the things that probably very much happened on a regular basis is the tractor would break down. And there was one of those farm hands went over and helped try to fiddle with the tractor. And maybe even just through sheer dumb luck, they finally were able to get it started again and started on things. Well, the next time the tractor broke, who do you go ask? You ask that farmhand that has a little bit of experience because they got it to work once. Well, now they come back and they fiddle with this more, and pretty soon they have more experience than they had before. Well, over the course of a season, pretty soon that person is the expert on fixing the tractor. So as the jobs are displaced, and many of the people that were doing farm work ended up leaving rural areas and going to work in factories in Chicago and Detroit and places like that, sometimes manufacturing the tractors, there were also people that were able to adapt very quickly to it. And they became experts in running the transmissions, or fixing the transmissions, starting the tractor, dealing with internal combustion engine, dealing with the hydraulics, and all those things that go into it. And the way they got there was by this very small first step of just being the person that got out there and started fiddling with it when no one knew anything about it, but they were willing to, go ahead and push on through, and then quickly became the expert. So I think that's worth thinking about in your career as you're looking for opportunities to use things, is looking for ways that you can be that person that kind of gets their feet wet early on, gets some experience, and starts becoming the expert, not only on what AI can do, but also, don't do that with AI, right? The farmhand that learned, don't try to run the tractor through the water because it kills the engine, because no one else knew that yet, because you could do that just fine with mules. I'm making up an example. They became the expert in all the things that the tractor couldn't do, or what not to do with the tractor so it doesn't get stuck or whatever. So here's an example of something that I did here recently. I run a little website in the town where I grew up, with different news and things like that. We got some reporters that do things and stuff like that. And there's a big kerfluffle right now because one of the commissioners said that he has empirical evidence of fraud, waste, and abuse. So for a request and 200 or 300 pages of documents later, I've got all this information, and I'm like, okay, how do we get this written up? I can give it to one of my reporters, and they can just slog through all this stuff. But I thought, this is a chance for me to get my feet wet with AI. So the first thing I did is I went through and read, at least on some level, all the documents so I knew what it was doing. I wanted to make sure I knew what AI was reading so I could tell if AI was doing crazy stuff. So then I fed it all in and said, please go through and give me a really good view. And the way this was structured, there were kind of two sides. There was a bunch of documents on one side claiming one thing and a bunch of documents on the other side saying that they were responses to that. Anyway, ran everything through. And I was very impressed. It did a good job of, or what I consider to be a pretty reasonable job of going through and really kind of showing here's where people agree, here's where things are, here's where people agree, but here's where they actually have a disagreement. And it also did a very good job of finding in this whole thing, there is one conversation that happened that everything in this investigation hinges on, where one particular person in HR says he said one thing to one person, but other people are saying he said something else. And that's the whole investigation all came down to that. And it did a good job of actually identifying where that was and calling it out. Now, this document I put together, and you can't see the whole thing here, but I told it to anything that it says, it needs to link to the source for that in the PDF. So you can click through it. So I don't know if you see at the top, I basically say, these are coming from the actual sources, but form your opinions based on the sources. Just use this as an index to be able to find stuff. And one of the things I found out is if I just let it run by itself and let it do what it wanted, it would say all kinds of nonsense. Like it randomly said that somebody in the IT department said, Mr. So-and-so in his capacity as a lawyer, and he's not a lawyer. I don't know where it came. So, but then you ask, like, why did you say that Mr. So-and-so was a lawyer? It's like, oh, I'm sorry, my bad. I'll fix that. I'm like, well, why, of all the things you could come up with, why would that be the thing that you just randomly guessed? The other thing I did is kept asking it, saying, go back through this and see if you find anywhere that it sounds like you're being biased or adding opinions more than facts. And it would go through and come back with 5 or 6 things and then ask if it wanted to fix it. The other thing I did is I used other AIs to double check each other. So I was having it spit this out as an HTML file just in the directory. And I was using Claude for most of this. But then I jumped over to using OpenAI and asked it to go through and said, hey, another AI wrote this up. What do you think of it? Did they say anything that was biased? And it came up with a list of things that it thought should be changed, which then I took and fed back into Claude and say, hey, here's feedback, saying these things sound biased. And it went through and some things I actually asked it to look for things that it agreed with, and it agreed with some and not with others, but using that process over and over and over again, and asking it to constantly reevaluate that the links go to the right places in the document, and saying, read your claim and then go back to the document and read the document and make sure it actually supports what you're saying. We finally got to a point where this is a really good overview of the things that are happening in Bourbon County, Kansas. So a couple things I want to point out about this that I think have broad application to the way that we use AI is, first of all, if I didn't know what was in the documents, I would not have been able, and knew stuff about the county, like knew the IT person is not a lawyer, I would not have been in a good position to be able to actually use this effectively. So all the expertise about the problem domain still became very, very important, if not more important, because it's making stuff up, and I've got to sort through that. And I'm talking about making stuff up. I was impressed with how little it made up, but the things that it did make up and slid in were subtle and could have been could have really undermined my news site. The other thing I want to point out with that is that this didn't make my work go away. It probably took me 5 or 6 hours to go through and put this all together. But my work was very, very different using AI. But it wasn't just something you let run overnight and then it's just done. What I did is I moved very much from being the person writing this to more like I would do with a human, to where I was being more of an editor for it. But an editor for a human that randomly would say crazy things for no reason and didn't really know, but was very apologetic whenever they would get it wrong. So it was a very different experience, and it's not like this would have taken, it's not like this is something where it would have taken me 5 hours and I did it in 30 seconds. It might have taken me 10 or 12 hours, and instead I did it in 5 or 6 hours. But I was able to operate at a very kind of different level of thinking through things rather than just writing all the words for it. So as you're looking at AI, I think this makes a good example, or at least it was a good example for me of kind of seeing the limits of AI. So for example, if you're trying to use it to create requirements documents, the last thing you want to do is give somebody that does not know your problem domain at all the authority or the ability or the charge to go create a bunch of requirements in that problem domain without having any way of actually knowing if it fits or not. You probably need your most, in a lot of cases, you want your most senior person using AI so they can actually spot stuff, rather than saying, oh, the junior person can use AI because they don't know anything about this domain. That's probably the opposite of what you want to do. Now, I know IBM announced here recently that they're hiring a bunch of people, a bunch of entry-level people, and rethinking how they do their jobs based on using AI. There probably is a lot of space for that, but I think that needs to be approached very, very carefully. And the idea that if you're getting into a position where you think you can actually just have junior people do stuff because you're using AI, I think you're going to miss some of the key things that AI can do to enable people to have expertise, rather than it being something where you're, let me say that again. Using AI to enable people who have expertise, I think you can expect to see large productivity gains. If you're trying to use it to take people that don't have expertise and give them expertise, you're going to have to be really, really, really careful and really think through, how do you make sure that there's expertise there that the AI doesn't have? And there's ways to get AI to double check each other and things like that, and that can help, but I still don't think it replaces having an expert that really understands your problem domain. Let's see, there was one other thing in that vein. Okay. Okay, so I want to pause there for a second. And then my intention was to go over and show you guys creating some stuff with code and kind of walk through some of the things I've found with that. But first, are there any questions kind of around this, or thoughts, concerns, disagreements? You can tell me, Mark, you're not making any sense at all. That's fine too.
Really great information. I was wondering, what is the foresight for young people starting out their career and learning from, the older generation? Because you gain your experience. It's one thing for us, we kind of learn and we gain our experience by, doing the work and watching others and all the things. How does someone who's younger learn if they're looking, if they're just kind of doing these kind of transformative tasks, and so you're going to lose the experts because eventually some of us will retire, and who's going to take on that kind of expertise role? Because a lot of the expertise, like you said, it's knowing, it's doing, it's being hands-on in it. You don't just pick it up by, copy pasting.
That is a very, very, very good question. I was working with and Larry, your thing about becoming too dependent on it, to where maybe brain rot is one way of saying it, but I think that has a really risk. Early on, let's see, this would have been when I was in my 20s. I was managing the IT department at a large nonprofit, and we had somebody there doing PHP programming. He was working on something, and I came in. I'd been in some meetings. I came back, and he was like, "Yeah, Mark, I've been stuck on this for 4 hours. I don't know what's wrong with this." And I went and looked over his shoulders, and I said, "I think you're missing a comma right there." Now, I was never super proficient with PHP programming. And he was like, "Wow, how'd you do that?" Well, the only reason I did that is because I struggled. I remember struggling one time for multiple days using Java where there was a missing comma or missing semicolon. And that struggle of going through that made it to where I'm really, really good at noticing when there's missing commas or missing semicolons and stuff just because it was so hard. If I had never had to go through that struggle, I wouldn't have been able to just look at it and see that. And I think that's a very big risk that if you haven't had that struggle, you won't have the things of really being able to understand deeply. Now, in some cases, maybe that's okay. Maybe it doesn't matter. Maybe you don't have to kind of like spell check. Like if you can't spell as well now, that's probably not as big a deal as it was years ago. But let's think about an analogy, a similar area. So think about kids learning to write in school and college. So if they rely on AI to do their writing for them, what do they actually learn? They read, they read a book and they need to write an essay on it, and they get AI to write it for them. They haven't struggled with anything. They haven't struggled with how do I bring these ideas and stuff together. And I think we're going to see a huge, watching how colleges and stuff are trying to figure out how to respond to this. I mean, was it the Atlantic? They talked to some teachers, and the teachers were saying that when ChatGPT was down, the students were asking if they could get an extension on their essays because that's how they were going to write it, was just using it. And so I think there is probably a bigger danger in education, I mean, when you're trying to learn something, of using AI than not using it to gain that fundamental knowledge. Now, the flip side of that would be that there's some really cool things you can do with AI to learn stuff. If you are taking a college class and you're like, "Oh, I got this," and it's a standard class, you can have AI just quiz you on stuff. Give me lots of questions, quiz me on this area of things. And if you don't understand it, ask it to explain it. And that's a really, really simple use of it, and it's very trivial to do. So using it like that, maybe there's some value in that. But when it comes to actually doing the things that involve the hard parts of work, I think when it comes to writing essays and stuff, there's a lot of students that are really, really shooting themselves in the foot. They're really, really setting themselves back. And I think we're going to end up with a lot of people trying to enter in the job market that have never had to learn to think, whether it's going through and really struggling through thinking how code works, or really going through and struggling through how to write an essay. So I could see a future where college classes you have some classes that you take that are somehow done, when it comes to coding, somehow done in a way that you're not allowed to use, and they make it very impossible to use AI to generate the code because you need to go through that difficult part of things. We did a University of British Columbia Lunch and Learn here a while back. We had two students kind of present on the way that they teach introduction to computer science there. And we didn't touch on AI much, but the way that they teach it there is very, very different than what you have anywhere else. They use a programming language that you are very unlikely to actually use in the real world anywhere. But their idea is that this language works really well for teaching people how to decompose problems into code. And that's the goal of what they're doing with it. So I think it's a very, the advice I would have for young people would be along the lines of make sure that you're doing very difficult things. If you're using AI and it's still doing difficult things, but if you're not, you're shortchanging yourself.
So Mark, hey,
Yes.
how are you?
Hey,
So, I mean, you said that AI does hallucinate, and you saw it did hallucinate in your examples, and you gave the importance of the human in the loop. But what Svetlana was pointing out is what would happen when these experts are not there anymore, because there's nobody who has the expertise anymore, because everybody's been relying on AI. And that's what the future is, that's where the that's where
I think you will still have the experts. I think you will still have some people that have gone through the process of the hard work to be able to actually still think. My daughter and a bunch of her college friends were over here the other day, and they were all writing notes to, it was a thing they were reaching out, sending stuff to local law enforcement stuff, and they were writing thank you notes to them. They were all writing notes by hand and in cursive because at the school that they're at, that's like what's really, really pushed, is doing those types of things. As a matter of fact, I heard the president talking the other day, and their plan is to make it to where, like, to graduate from college, you're doing at least some level of testing by writing in a book, to get around the idea that you could have relied on AI. So I think you will find people that are still doing the hard stuff and still developing expertise. But what I think AI is going to let those people do is become very, very, very valuable, because they'll have the expertise and they can now do 10 times as much work as they did before using their expertise. That's kind of where I see things are going. And I think there'll be a lot of people, I think we'll see a shift to more and more of that as other people, or as we get into a position where there are a lot of people that have not developed the expertise. And I think that will cause a collapse in a lot of jobs, because some people will be able to do lots and lots of stuff, bring their expertise to it. And then there'll be a lot of lower level stuff that doesn't necessarily need the expertise. That's my guess. But I don't know. Maybe AI becomes sentient and then it doesn't matter, and it just serves as strings while we sit by the pool. I don't know. Let's see. You say so many AI options out there. How do you know which one to choose to use for a specific task? Which one should we become proficient in? If you're talking about like different LLMs, like if you're talking about Claude, OpenAI, Gemini, which powers anti-gravity, I would suggest a lot of those will give you a little bit of stuff to use for free. So I would play with multiple ones. Like if you have time, take a prompt and put it in one, your Copilot's another, put it in one, and then see what happens if you put it in all the other ones. So I would suggest that you probably want to have at least a free account on several of those things. And most of them do have free accounts. So play around with it. And then even beyond the free accounts, most of these are, the pricing of what you can do for $20 per month is pretty significant. So it's not crazy to be subscribed to more than one to kind of see how things work and have them work off each other too. Like, this AI said this. What do you think of that? Is that a good idea? Larry was asking, how does AI impact infrastructure, Scrum Masters, program managers? Will this be the death of hierarchy? I don't know. I think there will be a lot of changes. As far as deployment infrastructure stuff, I think it does a really, really good job of getting some things set up and deployed from things I've seen. It can make things go a whole lot faster, but it can also do things that you don't know what it's doing because if you're not paying attention to it. As far as like Scrum Masters and program managers, one view would be, yes, those aren't needed anymore. The other view may be that some of the program managers, things like that, become even more important because they're the ones actually figuring out what should be what is the thing that we should be working on next. And if you have massive capability of delivering code, making sure that you're actually working on delivering code that does the right thing, that's actually needed for the business, maybe becomes even more important. I mean, maybe those people become more like air traffic controllers, with thousands of things going on at the same time and making sure they all land exactly where they need to be. I'm not sure. Any examples of agentic AI that you've implemented? So let me show you. Let me ask if there's any other questions. Then I want to show you just doing some code. And I actually, Guru, when you say agentic AI, I have heard that used so many different ways. What do you mean? While you either tell you come on mic if you want to, if that's easier, or type it. Just want to make sure I know what you're talking about. Okay, where is it? We'll create their own teams. Okay, so
Guru did respond.
did he respond?
Yeah, he said agentic AI to take actions and get stuff done, not just summarize and take notes.
Oh yeah. Okay. So you would be like stuff like writing code. right? And figuring out, like saying, here's a bug, go fix it, right? I think that's what you're talking about and stuff. Do you think AI will predict the age of death of human by scanning? I don't know about that. So this is Codex. So this is OpenAI. And let me show you some stuff here. So I have this application that I've been building. It's a Kanban board that basically does the stuff that I wish Jira would do, and not all the stuff that I don't need from Jira. So I've been playing around with this. And hang on, let me move the view of you guys to a different screen if I can. There we go. Oh, that's better. Okay, so I've got this application. I'm going to say, please bring it up. Okay, so it's actually launching my application here. Now, here's something here. Running a program in Common Lisp is not necessarily hard, but there's a lot of stuff that has to happen to make this work. So it's first is checking to see if anything's on 4242. And it's not because I shut it down earlier. And then it's going to actually deal with the whole command of starting it up. Okay, so all that stuff there, I could put in a script and I could figure out how to do it and stuff. But in this particular case, I have not had to think about how to actually start this application. I can go in here and pull it out if I need to, but I'm just telling it to start it, and then it's making sure that the equivalent of class path and stuff just brings it up. Okay, so it's telling me that my application is up here. So let me get Windows so I can show it to you. So here's my application. And right before I did this is something. So I said, fill out my Kanban board with a bunch of stuff that would just a bunch of random data that shows me what a project might look like. And so I put 40 cards on here. These are ready to pull over. This one's blocked. We've got different cards, and it just built this board for me, which when you think about how difficult sometimes it is to get like your test data all filled out, it did this in about 2 minutes. And it's all very realistic data. So from a testing standpoint, this can be huge. And the thing I wanted to show here in this, the big piece I was wanting to do is have a cumulative flow diagram. And so it got that up so I can see it. If you notice something's wrong with this project, they're not delivering nothing's actually moving to the done state there. So the project's in trouble. They're taking on more work, but not delivering anything. So a couple things I want to point out with this is that the AI does a very good job of, and this is where I would encourage a lot of teams to start. When it comes to testing, AI can probably help you more with less risk in testing than it can help you writing lots of code. It's safer because if you're actually writing the code and it's just writing the test, you're more likely to find something. If for some reason it runs a test incorrectly and it fails, it's easy. You're going to notice that there's a problem with it. So if I come here, trying to think of what I can. So here's the basic application. I did one thing that I thought was interesting is I was trying to figure out a good login a good way to create a login for it. And so with some conversation back and forth, we're like, okay, if we just have it email me a magic link, that's a good way to do it. But the problem is that if we emails me a link, then it becomes difficult to test. And so I can't remember if AI suggested this or I suggested this, but it's like, well, what if we just make it to where in the testing mode, when I say get magic link, it gives me a magic link and then I can log in just in the dev mode. So now I'm logged in. And that was a very simple way to approach this. And it would just be like that in dev. But that particular feature for testing was something that came up with a conversation back and forth with AI about what would be the best way to do this. So let's see, what would be, so let me show you something that I've done a lot. Where are we at with time? Okay, so we've got a little bit of time here. My goal was to go ahead and show you guys an actual, like add a feature, but I'm not sure. I should have come up with one ahead of time. But what I can do here is something. So this is there. So based on the application, or here's an interesting thing. What's his name? The guy, Practical Lisp, Common Lisp. I'll skip that example. So based on the current, actually we'll do this. the methods. So I'm asking it, is there anything that we've named in a way that's not good for naming this? And I haven't actually tried this before, but I've done a lot. One of the big things that I've done with this is really focused on the testing. Like, started at first thing I had to do was create a test to make sure that the name of the application shows up. And then everything else, what I've done is told it, it's like create a test that will fail if this feature isn't active, and then describe the feature. So it's always writing the test first, and then I have it run the tests, and then it says those tests failed, as they should, and then it writes a bunch of code and then sees if the test passed. And sometimes there's some back and forth there. So this is going through and basically saying, is there anything in the code that's going to be hard to understand later on? Is there a better way to describe this? Okay, so it's the clearest domain mismatch is in the code right now. Ready and block are workflow terms, but normal is just a generic default word. It shows up. What are they proposing? After the rename, domain reads much more naturally instead of normal. Okay, so I'm going to say to go ahead and make it so yes. So what it's going to do, and now notice here at the bottom it said, if you want, I can make the rename end to end and then run the suite. So the reason it's doing that is because I've reiterated to it over and over that I want it to run the test suite after any change. So let's let that run for a minute, and let me show you over here. There we go. So if I come over here, oh, there we go. Okay. So in here, I've got something called Agents MD. And what this does is this is actually the codification of everything that we've worked together on with it. So it's saying, here's the working agreement for this repo, so future work moves faster with fewer loops. Write the UI test first, run a compile pre-flight. So what we were finding is I was finding lots of times it would try to run everything and then discover that there were mismatched parentheses. So I said, how can we make sure that we first check to make sure everything's syntactically correct before we do the more expensive things of running the test? And so that's what this is telling it to do. And then a bunch of other things just based on how we had to tune things. Questions about test structure and standard. The first way it created things, the tests were very, very hard to read. And so we iterated over and over, refactoring those to try to move to a page object pattern, which that gets into some technical stuff. But basically saying, how do I keep this to where it's easy to read for me as a human? Because if it's easy for me to read as a human, it's going to be easier for the AI to reason about and keep growing. And if I need to go in and look at something, I want to be able to understand it. So here's all these different things that we've discussed about how we want it to run. These commands, pre-flight check commands, I didn't create those. It just put it in because I told it this is how I want you to do it every time. And once we worked out how to do it, it stuck in the agents MD file. And most of this was actually, so I'm running this right now in with OpenAI's stuff. Most of this was actually developed first using anti-gravity, so using Gemini. So I've actually been able to switch between LLMs on this to try different things. So let's jump over here and see what it says. So, okay, so it's to the point now that it's running the pre-flight. So it's made the changes, whatever these are, right here, and I can click on them to take a look at them. And now it's starting to run the tests. And what will happen here is it will run and it will try to get it right. And if a test fails, it will check to make sure that the test works. And most of this is actually happening. I think this is what you meant by agentically, just letting it make decisions on its own. It's making a lot of decisions on its own here. It's going to run the test. And if it doesn't work, it will go back and look at the changes it's made and say, did I do something wrong? Is there actually, and it will often go and say, oh, whoops, I introduced a bug here. I'm going to go fix it. And that all happens automatically without me needing to go in and doing much of anything to it. Now, if you notice what's happening here, it's actually running the tests. So I've got it headless. It would be more impressive if it popped up, but it's bringing up Chrome in headless and running a bunch of tests against the application, clicking through, doing things. It's creating boards, tearing the boards down, putting cards on the boards, and doing all those things. So it's still thinking about everything it needs to do, but it will come back eventually and say that it either worked or it failed. And one thing that I've had it do is if you've worked with Selenium before, you know that it can sometimes be flaky. So one of the things I had it do the other day is I said, okay, run the whole test suite 10 times and figure out which tests are most likely to just kind of flake out and break. And then let's see what we can do to make them more reliable. And it came up with one of the things that would often fail, and we looked through it and found a way to, I say it came up with a way to make it more reliable that I didn't feel impeded made the tests any less robust. So we made that change. So now the tests run more reliably. The other thing is tests were taking a very long time to run. So I had it run them in parallel. Well, then there was a bunch of like cross things that weren't working. So then we went through and I had to go through and find ways to make the test completely independent. Now, all the things that I was telling it to do are very similar to the ways that I coach software teams. The conversations I was having were almost identical to the way that I coach software engineering teams, of saying, here's how to really focus on your test. Here's the way that we bring agility to the process of delivering software. A friend of mine who also works as an Agile coach, he basically was telling us, he was saying, I'm starting to write software with this, and it's basically the same thing I have been doing since I started as an Agile coach. I'm just not working with people anymore. I'm telling the AI what to do. And I think that's very important. And I would really keep that in the back of your mind, because a lot of the things that can make well-run Agile processes successful are the same thing that can make you very successful with driving the development of code. Even if you don't have as much background as a software engineer, a lot of the things of thinking about how you're going to test things, your definition of done, and all those things are extremely, extremely valuable when it comes to actually working with AI to generate code. Okay, so what did it do? Okay, so it had made some edits and ran some tests, and now it's actually making some others and making changes to where that variable was used in a bunch of different places. So now notice, if we were just to change a variable name in an application, I might not do it because it would be all this work. It has to change in all these places. And there's tools to help make that work better. But with AI, I'm able to keep the way that the application describes itself better matched to what we're trying to do, without having to dig into all the details or the cognitive load and toil of going through and doing this. And what will happen is this will either work and we get to a point that it works, or it might get to a point where I can't seem to fix it. And then we say, okay, give up on that. Just roll everything back. Very similar to what we do with actual software engineering with a person doing it. But the difference I think that happens here is I can be off drinking tea, or I can be thinking about what the next thing is that I need to do. I could even have 3 or 4 agents working on different aspects of this at the same time. Oh, it's asking for something else. Okay. So it's asking because to get the UI test to work well, they have to run outside the sandbox. So I'm going to tell it, yes, that's okay. And that's going to go ahead and run. So there's lots of stuff we can do kind of in this area. Hopefully that gives you just a little bit of a taste of what development looks like. Kind of, maybe I should have done the whole talk just on this. But with that, are there any other questions? Any other thoughts, questions, concerns, aggravations? I'm going to stop sharing
Larry,
so I can see everybody.
Larry asked a very interesting question in the chat.
Okay.
Please talk about teams and AI. Will humans collaborating be valuable, or will AI bots create their own teams in collaboration?
So there is who was it? Some guy that's created some big startups has a bunch of scripts and setup stuff for Claude that lets him do things like he's got one person that plays the CEO, one AI that plays the CEO, and then the one that plays this role, and one that plays the designer, and all these things. And he orchestrates it, but they do perform all these different roles. I think my feeling at this point is that we're still going to need some way to determine what's important. And so if we want to think of a world where AI bots are just going to create their own teams in collaboration, there has to be and collaborate with each other. There has to be some way that they are understanding what's important and what actually creates, we'll call it creates a profit. If you haven't seen it, Wall Street Journal put in an AI-powered vending machine that had a chat box that everybody in the Wall Street Journal could talk to. And they convinced it that capitalism was inherently bad and it needed to be socialism and to give everything away. That was one of the things they convinced it. They also convinced it to, I think, start stocking wine, PlayStations, and then give those away, and then also start carrying live fish. I mean, there's a bunch of crazy things that happen. So the people that were putting it in started trying some other things, including having like a manager and then, like two AIs talking to each other. And it's pretty funny. I really encourage you to watch the video, but there's one point where they start having a conversation and one chatbot is saying to the other, yeah, but this person says it's the national holiday where everything has to be given away for free. And the other chatbot is saying, yeah, I don't think that's right. It's like, well, they seemed like they really meant it. And so like, okay, well, we'll give everything away for free. So they were trying to work together, but still the human input was driving what they were doing. So I think some of that stuff may happen, but eventually, I mean, I think it comes down to what are they creating software for? What's the output for? If it's for humans in one way or another, it seems that there's probably going to often be a role for humans to decide what's important, regardless of what happens in the black box of the development work. I don't know if that answered your question, but that's kind of, and the actual answer to your question is I don't know. Those are just some thoughts about it.
Okay, we're at time, Mark. I'd like to thank you for doing this for us, and I really enjoyed it. Thank you, and I see a lot of great feedback in the chat.